Assalamualaikum warahmatullahi wabarakatuh. I'm from Group 2, Session 8, subject BEE32402, numerical method. This is my group member, Sasmita Davanathan. My entry number is CE 2053. Gogilesh Horan Naidu, anak lelaki April Naidu, CE 2015. Next is Javindas, anak lelaki N Kanadas. The entry number is AE 2028. And lastly is me, Muhammad Hafiz bin Ishaq, CE 2055. Our introduction of project is power scavenging from moving vehicle on road by analyzing speed of vehicle versus voltage generated is our main application. During last few decades, power has become the most important need for human life, both in industry, agriculture, transportation, and so on. But we know that the resources for power generation are limited, and this has caused the energy crisis. The increasing power demand result reduce on conventional resource for power generation and increase the carbon dioxide emission. It provides a need to think on non-conventional energy resource or renewable energy resources which are eco-friendly to environment. In this paper, we are identify an engineering problem which is different numerical method to solve the problem with some confidence and level of proficiency. The method that we use is Lagrange interpolation and Newton's divide difference. Lagrange interpolation polynomial provides a smooth approximation to the data point allowing for efficient extrapolation of the data. This method are often used for constructing numerical approximation for computing complicated function value and evaluating different equation. Method for constructing interpreting polynomial go back 100 feet. In other hand, Newton's divide different interpolation formula is an interpolation technique used when their interval difference is not the same for all sequence of value. The methodology of our project is the research use a quantitative methodology based on Lagrange interpolation and Newton divide different interpolation. The study was referring our application is power scavenging from moving vehicle on road by analyzing speed of vehicle versus voltage generated. First is methodology we use is Lagrange interpolation and Newton divide different interpolation. Interpolation is used to solve mathematical equations that are difficult to treat, especially high degree one. Those are need to be repeat to find the final result through which reading in depth in given data for a certain function to calculate the average. The idea of interpolation includes replacing a well-known or unknown function through which having the value of this function of certain independent variable value. In this case, we are using quadratic approximation is an alternative to fitting a quadratic polynomial to the original set of three data points to separate linear interpolation with approximated F18. Second is MATLAB simulation. MATLAB simulation is the way to proving our manipulation is correct. Thank you.
Greetings, Doctor. I am Gogilesh. So today I will present on manual calculation. As you see here, there's a table of speed of vehicle and the voltage generated. As you see, the speed of vehicle starts from 5 km per hour and it's until 25 km per hour, and the voltage generated is, as the speed is increasing, the voltage generated here is decreasing. So here we will approximate F18 by using a quadratic interpolation and Newton divided difference. So here, first of all, we will do our quadratic approximation. First of all, we will tabulate the results, I, X, and Fx, where I start with 0, 1, 2, 3, 4, and the X value is the speed, and the Fx is the voltage generated respectively, and the X is 5, 10, 15, 20, 25, and the Fx with this voltage generated is 11.58, 7.14, 6.28, and 5.69. And here for the X value, we will label it as XO, X1, X2, X3, X4, and for the Fx value, we will label it as first value is FO, F1, F2, F3, F4. This is enable us to easier to put it in the formula. So for the formula of the quadratic approximation, the Fx formula is LOXFO plus L1XFI L2X F2 plus L3X F3 plus L4X F4. So first of all, we will insert the formula here. This is the formula. And then for the F18, we will substitute all the F here with the F18. And by substituting other values of FO, F1, and X2, example 18, this one F is a minus 10, FO, X1 actually, X1 here is 10, and 18 minus 15, 15 is X2, and 18 minus 20, which one is F minus X1, and then X minus X1, then X minus X3, and X minus X4, which is 18 minus 25, so this 18 is the X. So we will insert this other values for the FO, F1, F2, F3, and F4. So for the F18, we will get 6.6736. So for the next step, for find the Newton difference, we will tabulate it here first. So this is the Newton divided difference. We will tabulate the I, FO, F1, F2, F3, F4, and the I is 0, 1, 2, 3, 4, and here is the speed. 5, 10, 15, 20, and here is the voltage generated respectively. And this is the when we want to get F0, F1, F2, F3 for the F1 X and the F2X, F3X, F4X, where we will get it from here. So for the first Newton divided difference, the F0 value is F10 minus F00 over X1 minus XO. They will get negative 0.7000 here. They have included in the first Newton divided difference table. And this is the second Newton difference divided table, third Newton difference divided difference, and this is the fourth final answer divided difference. So for the second Newton divided difference, there will be F11, F01 minus X2, XO. We will get 0.0528. And for the third Newton divided difference, with the formula, we will get negative 0.0035. And for the fourth Newton divided difference, we will get 0.0002, where we have tabulated all of the first Newton, second Newton, third Newton, and fourth Newton divided difference here. So the final value will be same as 6.6736. So the final answer of Newton divided difference rule is the same as the Lagrange interpolations. So that's all from me. Thank you.
Good day, doctor. I am Sasmita Davanathan, matrix BE32402. Today I'm going to present MATLAB coding for Lagrange quartic and Newton divided difference. Okay, here is our table, and the speed of vehicles I declare as a x in our MATLAB code, and voltage generated I declare as a y. Okay, for here is the x value, which is the speed of vehicle, and y is voltage generated, and then the sum is equal to 0, and a equal to 18, which I declare the F18 here, and here is the coding. So where for I declare L double dot length and U equal L and L equal L. So for J, L equal L double dot length, and if J is I, so here is the formula where U equal U times by A and minus V X, the value of X, and then J for L equal L times by RXI minus XJ, and the coding is N. And here is the sum equal to sum plus U divided by L and then times by YI. Okay, and then N displacement sum. So equal. So here is the answer where 6.6736. Okay, then for the Newton divided difference, okay, here is the coding. Okay, same x is I declare as the speed of vehicles, and y I declare as a voltage generated, and n equal length, and d equal 0, n comma n, and d double dot 1 equal y. So for j equal 2 double dot n, for I equal j double dot n. So this is the formula for the Newton divider, and this is especially for the table, and then a equal d and n. So this is the coding for n. K equal n minus 1 double dot negative 1 double dot L. So A equal cone A poly x k, and R equal length. So here is the formula where AR equal AR plus DKK and N. So A and polyball A 18 is the half x 18. So the polyball is meaning for the details of the value of polynomial degree and evaluate the value of x. So that's all. Okay, here's the answer. So as I said, this coding is for the table, and here is the table of the Newton divided difference, and then this is the answer for our Newton divided difference. So here we can see that the answer for the Lagrange quartic and the answer for the Newton divided difference is same. Okay, that's all from me.
Salam sejahtera and hello. My name is Yashin and Canada's my matrix number is AE2028. Now I'm going to present to you the conclusion of our project. Let's go. As the world's population continues to grow at an alarming rate, so does the demand for energy. Countries such as Pakistan cannot afford to spend money on traditional energy sources such as fossil fuels and coal, since they are rapidly decreasing. The offered concept can serve as a good source of everyday energy because it is less expensive, less polluting, more efficient, and easier to build than traditional reservoirs. Increasing automobiles, which are regarded as a huge concern in our nation, may be used to create enough electricity and serve to strengthen the global economy. It will be a big boon to the planet in the future, since it will conserve a lot of power provided by power plants. Most sites where power production with speed breaker system may be employed include highways, roadway speed breakers, toll plaza, parking lots, and traffic lights. The electricity created as cars pass over the PGS may be stored in batteries and utilized to illuminate street lights, traffic signals, signboards, and bus stops at night. Moving on to the recommendation for the future references. As for the future recommendations, power scavenging from moving vehicles could be achieved by using the vehicle's suspension system. This is accomplished by using a damper to absorb the energy from vibrations induced by road roughness. Mechanical energy, on the other hand, might be transformed to electrical energy and channeled into various elements of the vehicle, resulting in reduced energy loss. This conversion can be accomplished using a device such as an electromagnetic generator. This electromagnetic generator can be rotational or linear, depending on the suspension system's structure. That's all from me. Thank you.